Okay, hello everybody. Today we're going to talk about requirements, what requirements are, and kind of why they're useful. And all of that is going to be kind of the first content lecture in the requirements gathering series of lectures in this module. It's kind of the first phase of the software development lifecycle. And so what we're going to do is we're going to cover first what they are, then we're going to do a little bit of investigation on how you actually gather them from the client, how you elicit those requirements. And then at the end, we're going to talk specifically about kind of all the pitfalls that you can encounter and how you can take a look at the requirements themselves and kind of get around some of those pitfalls. So today we're going to start with kind of an overview of what they are and why they're important. And so that's what we're here for. So in the past week, what we did is we really talked about software engineering in kind of general terms. And what I wanted to do is contextualize software engineering and kind of compare it to something that you're much more familiar with, which is basically just computer science coursework, right? Making a programming assignment, how that's different than making a full-scale kind of application for a bank or something like that. We also talked about the historical context of software development and maybe how that impacts or how that affects the way that we build software today, kind of the processes that we use, and how the agile methodology sort of came to be maybe the most popular way of doing software development. We also talked about how all of those new methodologies, so Agile, but then also Scrum and Kanban specifically, are adapted to support rapid change. And so they recognize that clients are apt to change their minds, contexts are apt to change, and so software development teams have to be as agile or as flexible as possible in order to stave off overages and kind of deliver on time and also deliver under budget. And so this week what we're going to do is we're going to talk about maybe the biggest part of that. And so requirements gathering is often thought of as maybe the most volatile part. And it's also the part where things are more likely to kind of blow up. You're more likely in this phase to see a lot of changes, and you're more likely to experience why Agile has become so important to software development kind of in general. So the purpose of requirements gathering is really to make client requests concrete. And so at my company, we kind of have this one central inbox, and that inbox accepts a whole bunch of different types of emails from potential clients. These things can be simple IT problems. My printer stopped working. Can you please help me with my printer? But it also includes things like custom development requests or opportunities for us. And so in a very real sense, you can get emails that say something like, hi, we need you to replace our entire claims system if that client is an insurance company. And so going back to the waterfall example that we were talking about last module about building a building, it would be something like if somebody came to your house and knocked on your door and then said, hey, I need a building to be constructed and it has 4 walls and here's the address. I'd like to see it done by next Tuesday. Okay, bye, thanks. And obviously that isn't necessarily a situation where you're going to be able to go out and give the client exactly what they expect, because your very short conversation with them gave you no real insight into what the client is actually wanting. You know that they want a box, but you don't necessarily know anything about that box. So suffice it to say, one does not simply go out and build a claim system. These things can have any variety of sizes and shapes and complexities. You don't even necessarily know what type of insurance the company is selling or maintaining. So obviously a single email that kind of gives you a directive is not sufficient for you to have information to build the system. All you know is that there is definitely a client in need of a system, but the directive doesn't actually give you any information on what they actually need. So in a crazy percentage of cases, most of the requests don't have any information that would help you build even an estimate. So if a person comes to you and says, how long will it take you to build a building? It's going to really matter if the building has 900 sides and is this intricate sort of architecture versus is it just a sort of shed or a pole barn or something that you're erecting in someone's backyard. Those things have various levels of effort required, and software is no different, right? So if you're trying to build a claim system for maybe a mom and pop insurance company that maybe has a couple dozen clients, versus you're trying to build the claim system for Allstate or for Geico or for one of these very, very large corporations, that is going to be a vastly different level of effort on your part, and that's going to provide a different estimate of work, obviously, for whoever the client is. So it is virtually impossible for you to give an estimate to a client without any idea of the shape of the system. So if you don't know that they have 10 million users, you're going to be apt to maybe underestimate the amount of time it's going to take you to build the system. And if you underestimate the type of business that they do, so if they sell 5 or 6 different types of insurance, you might short sell yourself on the number of screens that you have to develop or the number of different UI elements that you have to develop. So what software requirements at their base do is they break down this kind of directive client request into bite-sized pieces that are measurable. So the idea is that you can take this kind of ephemeral idea of building a claim system and you can write out, even if there are 1,000 requirements, you can write them down on a piece of paper. You can look at each requirement and say, hey, this one's going to take 15 minutes and this one's going to take 4 hours and this other one's going to take 6 days. And at the end, you can aggregate all of those things together and you can give an estimate that's fairly tight to the client. And not only can you do that, but you can also use those kind of like tasks inside of Asana or something like that. You can design the component that meets each of those requirements. You can implement that designed piece of code. You can test it, and then you can deliver it to the client and have the client sign off on each one of those things. And so the idea is if you have a very tightly controlled list of requirements, you have passed those through each of these different phases, and then the client has signed off on them, then the work is done. And so you and the client have agreed that those are the requirements that the system needs to meet. You have received approval and you've received sign off on each of those things. And so now you can reasonably expect to get paid the full amount, and everybody's kind of happy. There's no confusion between the two groups of people. So throughout the study of computer science and probably throughout a lot of the coursework that you've done, you have undoubtedly heard the phrase levels of abstraction. And so this is often a thing that you see in something like object-oriented programming. And requirements themselves do not necessarily all have the same level of abstraction. And there are two kind of ends of the spectrum that we can talk about, and then there are all sorts of requirements that kind of fit in the middle. But on one end, you have high-level requirements, and those high-level requirements give you a kind of general idea of a component and what that component should actually do. So this could be something like a high-level requirement that the system, the insurance system, has to send secure messages out to the users. But there are also low-level requirements, and so low-level requirements give a lot more detail into the how of a high-level requirement. So it actually tells you what kind of secure message, for example, and these are kind of closer to almost implementation detail level requirements, but they specify sometimes the protocols that need to be used and things like that. So as an example, a high-level requirement could be something like we were talking about, right? It could be something like if you have a claim and the insurance company needs to go back to the healthcare provider and get more information about what that claim is paying for, that communication has to go over some sort of secure communication channel. So that could be secure email. It could be a portal that is set up that only logged in users can access, anything of that kind of nature. And so an associated low-level requirement could be something like a system that will actually detect if the communication contains what's commonly referred to as private health information. And if it is, it will automatically encrypt and secure the email. So it allows email that is not secure as long as there's no personal information in the email. And once that personal information is identified, then it switches automatically over to an encrypted email. And so the point here is really two things. The first thing is that the high-level requirement requires a secure communication channel, but it doesn't actually tell you how or what kind of secure communication channel, and it leaves a lot up to the imagination. And so the more a requirement leaves up to the imagination, obviously the more likely it is that what you develop or what you design is going to be different than what the client expects, and that is not necessarily a great situation. So often, high-level requirements are used to keep things on track, so you can track how complete this high-level requirement is, but you also need low-level requirements that actually tell you how that high-level requirement should actually work. And so this low-level requirement is telling you exactly what the user experience should be around what that requirement of security is. The second thing is that the low-level requirement still contains some ambiguity. It doesn't actually tell you how to go in and code out what the requirement's code implementation looks like, and it shouldn't do that. So things like specific platforms that should be utilized, and things like code snippets that perform this requirement. All of that kind of stuff is actually an architectural decision, and we're going to talk about that in Module 3. So all of these requirements should not necessarily get down into the detail of physically how it should be done. Even low-level requirements should be giving you kind of a high-level overview of how it should be done. So this would be something like explaining how a user would interact with this specific requirement, but it would not necessarily be code samples and that kind of stuff. So in addition to having various levels of abstraction or various levels of detail, we also have two kind of main flavors of requirements. There are functional requirements, which are actual behavior that the system should have. So if you have a send email button, a functional requirement would look like when I click that button, a dialog box should open up and let me specify the body and the subject in the to line of the email. So this functional requirement is actually telling you what the system is going to do, and it's pretty easy to test functional requirements because you can go through and you can press the button and you can visually inspect and verify that the dialog box actually does pop up. Now, there are places that would split even this functional requirement into much smaller functional requirements. So it would be something like the dialog box should have a subject line, and the dialog box should have a body text box, and the body text box should support both rich text and HTML, and on and on and on and on and on. And you get this kind of idea that requirements gathering can be as deep as you want it to be, and it's kind of set by the software organization that's doing the development. And so here, the main idea is that the functional requirement gives us what the system is actually supposed to be doing, and even inside of a functional requirement, there could be many smaller functional requirements that are embedded. Next, we have non-functional requirements, and so non-functional requirements are less behavior and more a property. So in this case, we have a non-functional requirement that the system has a maximum latency for any service call of 100 milliseconds. And so this is a very common non-functional requirement for multi-tiered applications. The idea is that you are waiting around for the system to do its job anytime there is a service call outstanding. So if you have a whole bunch of service calls that are more than 100 milliseconds or more than 200 milliseconds or something like that, the user could experience severe lag in the UI, and because of that, they will stop using the application and be kind of sad. This is the other type of requirement, and basically it sets out properties that are in a lot of ways harder to test. But they cover things like performance or security, sort of more general concepts like that. So again, everything in the world, and by extension, everything in software engineering kind of happens on a continuum. And so it might seem like, going back to our example of the email dialog box, if you take every single requirement and you break it down into the most small sort of single unit requirements possible, and you spend hours and hours and hours and days and weeks and months going through and documenting and refining requirements to get the most perfect set of requirements ever, this will always lead to better software. And this is kind of unfortunately not the case. And if you think about the discussion that we had about kind of balancing too much and too little documentation last week, the exact same thing is true of requirements. And really requirements boil down to a specific type of documentation for a software project. So if you have too few requirements, so too few functional or non-functional requirements, the components themselves are what I'm using the technical term fuzzy. And the fuzzier those components are, the more likely it is that what you think the requirement should do and what the client thinks the requirement should do are different. And once that starts happening, there is deviation that you're going to have to spend time remediating. So you might make the dialog box one way, the client might expect it a different way, and so then you have to kind of negotiate the time that it's going to take to make your dialog box look exactly like the client wants it to make. And these very tiny kind of missteps, if you sum them up over the whole life of the project, can add up to a significant amount of time and resources. And that's a very common place that project overages can happen. Likewise, you could have potentially too many requirements, and once you have thousands or tens or hundreds of thousands of requirements, it's very, very easy to have those requirements become unsynchronized. So you could have a requirement that you have created that the dialog box should pop up after you hit the send email button, but once you actually send from the dialog should remain open. There could be a conflicting requirement that it closes after the email is sent. And because both of those requirements are in the system and there's no kind of weighting to those requirements, you have a situation where you can't have both of those requirements met at the same time. This is kind of a cooked up example, but obviously this is a thing that could happen if your system is complicated enough, and if your team is big enough, et cetera, et cetera. And so having many requirements just makes it all that much easier to have these kind of conflicting requirements that you can't have all at the same time. This often happens because changes to one requirement aren't propagated through all of the other related requirements, and the more related requirements that you have, obviously the more propagation you have to do, and if that's a manual process, you can kind of get into problems. So the same thing applies that applied with documentation. Trying to understand the right number and the right granularity of requirements is really an art, not necessarily a science. And so this will have a lot to do with the type of project that you're doing. It will have a lot to do with how much project management experience you have. It will also have to do with how much project management is happening on the client side of the table. If they are extremely unorganized, then a lot of the times you kind of have to over-organize in order to make sure that you're protected from risks to the project. So there is a thing that I cover in basically every class that I teach at the university, And at this point, if you've had any of my classes before, this will be review, and it's like I'm kicking a dead horse every semester. But one of the things that you will find out as you meet increasingly intelligent people through your life is that a smart person is smart enough to know that they don't know everything and admit the fact that they don't know everything. And this is due to, or maybe a corollary to, a psychological phenomena called the Dunning-Kruger Effect. And it, kind of the meaner way of saying it is what's used in the paper. So the quote is pulled from the paper that kind of explains what this is. But it basically says that low ability people don't actually have the ability to recognize that they don't have the ability to do something. And so this is important to software engineering because I'm not necessarily saying that clients are incompetent, but I am saying that it's impossible for them to know what they don't know. And if they aren't kind of humbled by what they don't know, it's very, very, very easy for them to think that they're giving you all of the details and all the information that you need when in fact they don't. And it's also very easy for them to think that your job is basically a software engineer is a wizard, and you go away into some sort of hut in the woods and you come back with a piece of software, and they have no idea the complexities that go into that piece of software. So it's very easy for a person to come to you, send you an email and say, hey, build me a claim system, and then for them to be angry or agitated that you spent months and months building a claim system, because to them it's kind of trivial. They know how to do all the things. You should be able to teach a machine how to do it in a day. So the root of a lot of problems in software engineering is that clients don't often understand their own requirements. They don't understand and they can't hold in their heads, really no one can, all of the details of a system that they're using day in and day out, and they will always, mostly by accident, leave out some key detail that is going to make your life harder as you go through the project. So they very often understand a lot of their requirements, but they also very often don't understand all of their requirements. And so it's possible to, in a real sense, kind of paint yourself into a corner, and then they give you a new requirement. The system is not compatible with that requirement, and then you have to do a whole bunch of remediation to understand how to shoehorn a new feature or try to adapt to a new situation. And this is exactly what we were talking about last week, when suddenly you find out that you have to run your system on some sort of ancient machine from the 60s that they have stored in a broom closet somewhere. So a very, very common, again, kind of corollary or lemma to this is that the client will come to you and they will give you a list of kind of fuzzy requirements. You will give them a follow-up and say, hey, well, what do you think about XYZ? And the response will be something like, I'll know it if I see it. Or, yeah, that sounds great. Let me see what it looks like. And the problem there is it's going to take you time to build the thing to make it look like what you're trying to explain for them to tell you that it's wrong. So we're going to talk about rapid prototyping, which is one thing that will help you with this. But don't be shocked when this is the type of response that you get from a client. Very, very often, clients don't have the time to sit aside and kind of thought experiment about what a system should actually be doing. But they will take the time to be angry about whatever shortcoming your project has because of the lack of that planning. So we talked about the shortcomings of waterfall last week, and one of the things that we said was particularly problematic about it is that with waterfall you could gather a whole bunch of requirements up front. Those requirements could be fuzzy, they could be incomplete, they could be bad for various number of reasons, and then the client could wait for months, they could wait for years, and then suddenly see the project for the first time, and it could be vastly different from what they expected. And this is kind of the worst case scenario for everyone, because the client is angry, they feel like they've waited a long time for a system system that is fundamentally flawed, they're not going to be able to use. It's frustrating for you because you've spent all of these months and potentially years trying to build a system exactly how you read it on paper, only to be told that you're not going to be paid because it doesn't meet the requirements that the client thought that they were kind of concretely and very clearly giving you. So one of the very popular and kind of easy ways of getting around the problem is to use what's called prototyping. And so the idea is you build a very small, kind of pruned out version, particularly of a UI or a very simple application that does one specific thing very, very well. And you get immediate client feedback on that prototype. And so if you do online gaming and things like that, you can think about beta testing. This is very, very similar to beta testing, except it's almost closer to an alpha test. It's something that maybe you can hammer out in a couple of hours, maybe a couple of days, and you can go to the client and get immediate feedback, and you can make all of the tweaks before you've invested a whole bunch of development resources in building a thing that they don't want. So the idea here is you want the prototype to be as close to a facade as physically possible. And this is really the gateway to agile development because what it does is it takes requirements and it bakes a very concrete visual thing out of those requirements. And then you can get the kind of thumbs up or thumbs down based on what the client thinks about those requirements. And so the visualization that prototyping gives you is very nice because the client and you not only have a verbal understanding of what the application should do and what the application should look like, but you also have an example. And as you have probably gathered from your years of college experience, examples are really, really important for understanding concepts that may be a little bit confusing at first. So if you can't possibly get a prototype built for every requirement in a system, so you don't necessarily want to build a prototype and then build a prototype for every individual feature, what you have to do is you have to rely on your ability to go back to the client and kind of pull information and pull requirements sequentially out of them. This is often referred to as eliciting requirements, and this is a fundamentally kind of core skill for software engineers that has almost nothing to do with technology or coding at all. This requires you to be something closer to a priest or a therapist or a bartender or something. You have to be able to have conversations about a business that you are probably not familiar with, a business that you probably don't care about all that much, and you have to have a conversation that's meaningful enough for you to understand the business context that the person exists in, enough that you can support that business context. And so you have to learn through a client relationship about what insurance even looks like, and then you have to ask questions and get meaningful answers for those questions so that you can actually build a system that makes sense. So in a very concrete, very real way, eliciting requirements is the difference between projects that flop and projects that don't. If you have software engineers that are very good at eliciting requirements, you're going to have a much better foundation to build the project on. If you are very bad at eliciting requirements, you could get lucky and you could just build a system and somehow the client expects exactly what you delivered, or the client has a very low bar. They accept a lot of unknowns. Most of the time, if you don't elicit requirements correctly, what's going to end up happening is you're going to build A, the client is going to expect B, and then they're going to be very agitated, and you're going to have kind of a problem trying to get them to pay or supply enough resources for you to get the project back on track. So one of the things that we're going to talk about this week that's really, really important to keeping a project on task and making sure that you're not going to get into a situation where clients don't want to pay for work or you have a hard time getting enough resources to get a project back on track to the point that maybe the project gets canceled. Is project scope. So what project scope refers to is all of these requirements summed up together. And so if you have a list of 10,000 different requirements requirements of a system, all of the work that's required to make all of those requirements or support all of those requirements, that is the project scope. So from the perspective of the actual software engineers, requirements gathering is building up the project scope piece by piece by piece. And so you think of all of these requirements as individual bricks, and the project scope itself is the building that you're trying to build out of those bricks. If the client, on the client side, is not great at providing requirements, and you on the software side are not great at pulling requirements out of them, what ultimately happens is you think they want a pyramid, and what they actually want is a square office building, and then everything kind of doesn't make sense. And fundamentally, it doesn't make sense because the scope that you have created through these bricks is the wrong shape. It doesn't make any sense to the client, and so they're not kind of on board with the project. Ill-defined project scope is the very first indicator, the very first step on what's called scope creep, which is, in my opinion at least, the #1 source of project overages in both time and money, and the most common reason for what I'm calling general malaise. Like the client becomes disenfranchised with the project. They start thinking about how the existing system is not that bad, or the existing manual process that they're going through only takes 4 days out of the 5-day work week. And because of the issues that they're having with trying to get you on board with what they are thinking, they could very easily just sort of cancel the project and write off the losses. So having a well-defined scope is absolutely paramount for success. And so while having a well-defined scope is not sufficient for success, I think it is necessary for success. If you don't have good project scope and you don't have good requirements for the project, you could get lucky, but it's very unlikely that you're going to get lucky multiple times in a row, and eventually something is going to catch up with you. So if you don't have problems in the first iteration of the project and you have a release, it's unlikely that you're going to have successful subsequent releases. So version 2 and version 3 and version 4, so on and so forth. So in kind of conclusion, to wrap up this part of the module, client requests, even implicit ones, at the football game, someone says, man, I really wish that you could build my banking system. That kind of stuff really marks the beginning of a project. And the requirements that you have to gather from the client, both high and low level and functional and non-functional requirements, provide all of the detail for whatever that client request is. So while a client request can be extremely directive and it can be very fuzzy, the requirements themselves, if you look at them in totality, all of them should sum up to be exactly what the client expects. And if you're marching toward what the client expects, then both the software team and the company that's actually requesting the work should remain happy for the duration of the project. We also defined what project scope is. So project scope is basically all of the work and all of the requirements summed together. And we've also gone over the fact that clients are very imperfect at providing all of these requirements. And very often it takes multiple meetings, kind of iteratively sitting down to try to understand the depth and the breadth of all of the requirements required for a system. So in the next lecture, what we're going to do is we're going to talk about how to actually pull requirements out of clients. So what are the types of actual techniques that you can use to become better at requirements elicitation, because it is such a key sort of fundamental skill, but it's also not something that comes up in data structures class very frequently. So with that, we will end this lecture, but I hope that this kind of gives you an overview of what requirements are so that we can start talking about actually trying to get them from a client. I hope you enjoyed it, and I hope to see you next time. Thanks.